Hi everybody, in this unit we are starting a new section. It's still Unit 8, but we're getting into proofs. And so today we're going to talk about some basic properties that we have to know for proofs. All of these properties are things that you've learned before, and I'm just going to go through and review them with you. But the addition property of equality, we know that if A equals B, then, for instance, we can add x to both sides, right? We've been doing things like that, and that's called the addition property. It says, okay, if you add it on this side of the equal sign, then you can also add it on that side of the equal sign. So if we know that A equals B, then we could say that A plus x is equal to B plus x. Here's an example with algebra that we've done like this before. So like, let's say we add 7 to both sides. Well, what that allows us to do is say 5x equals 30. We can also do it with geometry, that we can add something geometric to both sides. So like in this case, they're adding GH. So they're adding GH to this side and adding GH to this side. And when they do that, then they get this new equation, AB plus GH is equal to CD plus GH. Let's look at the next property. Same basic concept. Just like we can add something to both sides, we can also subtract something from both sides. So A minus x is equal to B minus x. If A equals B, then this can also be true. And so again, algebraically, what we do is we're going to subtract 5 from both sides. And when we subtract 5 from both sides, we get 6y is equal to negative 30. What allows us to do that, to add 5 or subtract 5 from both sides, is the subtraction property of equality. And once again, we can do this with geometry also. We can subtract a segment from something. So if we subtract this segment, then we get EF is equal to CD. Similar with multiplication. We can multiply both sides. So we can multiply an x times both sides. Sometimes when we do this in handwriting, we don't like put it in order. We kind of just put the x over here and the x over here, whatever. But when we write it out, we should put them in order as far as the property goes. Now, when we get into it, we might not be that picky about it. But in other words, if we have x equals 3, we could multiply both sides times 4 and say that 4x is equal to 3 times 4, or in other words, 12. And we talked about how if we have a fraction, we multiply by 2 in this case. And so the measure of angle ABC is equal to 90 degrees. That's an angle sign. I just couldn't figure out how to type it in. So that's an angle sign. Same thing with division. We can divide both sides, divide by x on both sides. That would give us A over x is equal to B over x. We do this in algebra all the time. We divide, like we could divide by 15. And if we divide by 15, we would get y equals 7. We can also do it with geometry, that we can divide by 5 on both sides. And we take this, divide by 5, we get 10. Okay, so those are our basic adding, subtracting, multiplying, dividing properties. We also have some others. So this next one is substitution. And we know this because we've done this before also, that we know if A equals B and we have an A over here, we can plug in a B for it instead. Or if x plus y equals 7 and we know that y equals 3, we can plug in a 3 in here and get x plus 3 equals 7. We're just substituting in. We've been substituting all year long, but we can also do this with geometry. So once again, if we know that a measure of angle A plus the measure of angle B is equal to 180, I can take, if I know the measure of angle B is 60, I can take out this and I can put in a 60 instead. And that would give me the measure of angle A plus 60 is equal to 180. I just took out the angle B and put in 60 instead. Okay, the reflexive property is interesting. It's like a reflection. And when you look in the reflection, you look in the mirror, you see the exact same thing, right? So it's kind of a funny thing, like, why bother? But we will find times in geometry when proving things that this is helpful, actually. So we can say that A equals A. Or we can say that AB, segment AB, is equal to segment AB. Or we could say that the measure of angle ABC is equal to the measure of angle ABC. It seems ridiculous, but it's actually helpful sometimes. Now the symmetric property, remember the symmetric is like I'm going to draw, we've done parabolas, haven't we? And we have, it's like the same on each side. It's very similar to the reflexive property. It's just that it's like opposite kind of. So if A equals B, then B equals A. Or if 5 equals 3x minus 1, then 3x minus 1 is equal to 5. So reflexive is the exact same on both sides. And you might take a second to write that down. It's the exact same on both sides. Whereas the symmetric property is flipped. And so again, you might take a second to write that down. It's like we have it here and we flip it to the other way. And so if we get to geometry, then we could say that segment CD is congruent to segment AB. And remember, congruent, that's what this little wavy line means. That means congruent. Okay, what would you say if I told you I have a favorite property? The transitive property is my favorite property. I don't know, I just think it's cool. If A equals B and B equals C, what the transitive property allows us to do is say, well, skip the middleman, just go to A equals C. Okay, they both equal B, so let's just make them equal to each other, A equals C. And again, we can do algebra too. 4y plus 1 equals 2x plus 3. Well, if we know that 2x plus 3 is equal to 5, then we can just skip the middle and just say, okay, then 4y plus 1 is equal to 5. And again, geometry also. We can just skip the middleman and just say AB equals EF, okay, because they both equal CD. That's the transitive property. I think it's cool. You just get to kind of eliminate a step. You get to skip a step. It's like in a board game. You get to skip over. Okay, distributive. We have been doing distributive forever. You guys know what the distributive property is. We're going to multiply this times this and this times this. That gives us A plus AB plus AC. We know we can do that with numbers and expressions. So that's 4x minus 20. I will also tell you that adding like terms, or I'll call it combining like terms. And so again, you might take a second to write this down, but combining like terms is also the distributive property. I don't think I'm going to get into that and like explain exactly why, but I just want you to know that that is the case. And sometimes I might call it distributive where you're thinking that's combining like terms. They mean the same thing. Okay, then lastly, the definition of congruence. Let me clarify a couple things. If we say that AB is equal to CD, that's like the measure of AB. That's how long is AB, like numbers wise. Then we can also say that AB, segment AB is congruent to segment CD. And I need to redraw my congruence. Okay, a lot of times I draw my little tilde backwards, so I think I did it right this time. If AB is equal to CD, then segment AB is congruent to segment CD. Same with angle measures. So if the measure of angle ABC is equal to the measure of angle DEF, then that means that angle ABC is congruent to angle DEF. See, I did it backwards again. Okay, this is a long list. We're going to keep this list and like have it open and use it because we have to use it all the time. All these rules, there's a lot of rules that we have to remember. Let's take a look at the next page and just use some of these rules. So the deal is, can we look at what's going on here and can we go back and remember our rules? So this one, I will give you a hint. It's my favorite. How do I know that? Because P is congruent to Q. Q is congruent to R. Let's skip the Q's and just go straight to P is congruent to R. What property is that? That's the transitive property. Some of the properties we can abbreviate, but some of them we can't because like substitution and subtraction, we don't want to abbreviate those. All right, let's look at the next one. X plus 4 is equal to 3x. And then we jump down to 4 equals 2x. How did we get from here to here? What did we do? Well, we subtracted an x. So this is the subtraction property. And once again, we can't abbreviate that one because subtraction and substitution are too close. Okay, x equals y. Y plus 4 equals 3x. X plus 4 equals 3x. Once again, how did we get from here to here? What did we do? Well, we substituted in. This is the substitution property. All right, let's look at this one. How did we get from this step over to this step? What did we do? We just flipped it over. Which property is that? Is it reflexive or symmetric? It's the symmetric property. And again, keep your book open. Look at the page and see which one fits. And the more, if you can flip back and forth and look, then that's going to tell you which one it is. Okay, this next one, if we know that JK is equal to PQ and PQ is equal to ST, then JK is equal to ST. That's my favorite one. That's the transitive property. I could tell because they just like skipped over the PQ and jumped straight to JK equals ST. All right, next problem. From here to here, what did they do? Well, they just added 5 to both sides. That's called the additive property, or the addition property. When you add something to both sides, that's just addition property. What happened here? We multiplied by 3. So that's the multiplication property. That one I'm going to go in and abbreviate because there's no other word that starts with mult. Okay, what happened here? We started with AB plus CD equals EF plus CD. But look, there used to be a CD on both sides and now it's gone. How did we get rid of it? We subtracted it from both sides. Let's look at this one. What's the difference? They look very, very similar. This one's congruence. This one is equal to. That's the definition of congruence. And sometimes, I think on the notes on the other page, it went the other way. It went equals and then congruent, and this time we're kind of going backwards, but that's still the definition of congruence. Definition of congruence is like you can go both ways. What do we say when something equals itself? That's called the reflexive property. All right, what happened here? I think we can see that, can't we? That's a distributive property. And this one, what did we do? We divided by 3 on both sides. That's the division property. Okay, that was a quick couple of samples. We'll do some more practice in class.